Okay. Okay, so we've got a 0.3178 gram sample of potassium hydrogen phthalate. So that would be KC8H5O4. We've dissolved it in 100 mils of water. Does that matter? Okay. We've dissolved it in 100 mils of water. We need 33.75 mils of sodium hydroxide solution to reach the equivalence point. What is the molarity of the sodium hydroxide solution? Okay, so yeah, I don't think we need that. Okay, so this the potassium hydrogen phthalate is going to give us K plus the hydrogen phthalate ion. Our hydrogen phthalate ion is going to react with water to give us the phthalate ion plus H3O plus, and then sodium hydroxide is going to give us HNA plus OH minus, and OH minus is going to react with H3O plus to give us water. All right, so our net reaction here, now I've balanced everything here. So our net reaction is we're going to cancel these, cancel our waters, cancel our H2O pluses, and so our net reaction is just going to be that KC8H5O4 plus NaOH is going to give us Na plus, oh, that's what I did wrong. So that would actually be 2 waters. Na plus C8H4O4 2 minus plus water. Yeah. Okay. So that's kind of our neutralization reaction. And so we have 0.3178 grams of this guy, and our neutralization occurs in a 1-to-1 ratio. So for each mole of our potassium hydrogen phthalate, we need a mole of NaOH to neutralize. So that's going to be how we're going to calculate the molarity in the end, is just by using that 1-to-1 ratio. So for our potassium hydrogen phthalate, we need our molar mass. So the mass of potassium is 39.0983. The mass of carbon is 12.0107. The mass of hydrogen is 1.00798. And the mass of oxygen is 15.9994. All right, and I don't think we need the molar mass for NaOH, but if we do, we'll calculate. All right, so the molar mass, the molar mass for potassium hydrogen phthalate is just the mass of potassium plus 8 times the mass of carbon plus 5 times the mass of hydrogen plus 4 times the mass of oxygen. Which, if we put in the appropriate values and run them through our calculator, we get 204.2214 grams per mole. Okay, so then we're given that there's 0.3178 grams. So the number of moles of potassium hydrogen phthalate is just the mass over the molar mass, which is 0.3178 grams over 204.2214. And checking our units here, the grams will cancel, the moles will come up, so that's good. And so our moles are 0.001556 moles. And so, because again, it's in a 1-to-1 mixture, that is equal to the number of moles of NaOH that we'd added to equalize, to reach our equivalence point. So that means that NaOH is equal to 0.001556. And it's asking for the molarity of the sodium hydroxide solution. So just the 33.75 mils, not the 100 mils. So just the solution that was added. So then the concentration of NaOH is just this molar amount over the volume. And molarity is in moles per liter, so we want to multiply by 1,000 mils per 1 liter so that the mils cancel and we get moles per liter. And so this comes out to be 0.04611 moles per liter, or keeping it to 4 significant digits, I guess. 44.611 times 10 to the minus 2 moles per, or representing it as molar. Alright. And, okay, so calculating the molarity. So I don't think we need to do that, we just need the number of moles. Okay, so substituting the values. Oh, okay, so it comes out to be the same number, which is good, but the way the person who solved it did it was to say that the molarity of our C8H5KO4, or our potassium hydrogen phthalate, must equal the molarity of the NaOH, which is true. And then using the ratios of the volumes, but it comes out to be the exact same. Solution is correct. Just going by a concentration route as opposed to a molar route, but that's still correct.